Hi, in this video we're going to talk about graph databases, a feature that's been around for quite some time within the database community, but pretty new to Microsoft SQL Server stack. It's been introduced in SQL Server 2017, and while it does a decent job of trying to give you an idea about what graph databases are, you need to understand that it's not fully ready yet, as with most features that get released in the first iteration, and there's a lot of additional features that most other graph database technologies have, but hasn't been fully functional or implemented in Microsoft SQL Server. The graph database is actually not very different from the old TB databases that we are used to, except it allows us to go ahead and look at the data in a slightly different way. To understand this, you need to first get an idea about the basic concept of a graph database, and then we can compare it with, say, for example, a relational database having a traditional primary key, foreign key table, and a relationship. Now, before I can get into the details, I'm just going to put this up here so you can follow it as we go along. Now, a graph basically consists of two parts. We have a node and then we have an edge. A node is typically something that you can define using a noun, for example, a place, a person, a thing. And an edge is usually some kind of action or verb. For example, you could have two nodes, something like person and location, and then you could have an edge that says maybe vacationing, so that you can establish a relationship between the person and the location in terms of how they vacation there. In this particular screen, I've given you two different diagrams of how a node and edge could be implemented for a scenario that I'm going to demonstrate. So one of the most popular graph databases that people, when they start working on, explore is the Marvel Cinematic Universe, or the Marvel MCU basically. And in there you have all these different cinematic characters from the Marvel universe. You've got, your Iron Man and your Hulk, and as part of the comic books, they often end up in each other's comics, and they have some kind of relationship in terms of who is a friend for whom and who fought with someone else. So if you analyze it in terms of a social network, you'll actually see there's a lot of similarities between characters in the Marvel universe and maybe people you might see on LinkedIn. And the intention here is to kind of explore relationships through the kind of interactions that happen, and it can be very insightful for a number of reasons. In this particular screen, if you look on the left hand side, we've got a node which is the person, and in there you'll see that I've got a list for both heroes as well as villains. And then you'll see there's another node over here which is called location, and the relationship between the node for person and the node for location is that there's an edge explaining whether that person lives in this location. In addition to that, heroes sometimes work together, in which case we have an ally edge, and also since villains are in the same node, we also have another relationship or another edge which is basically foe, which indicates villains who have fought heroes or vice versa. Now, to be frank, we don't really need to do it this way. There are other ways that this could have been implemented, because inside of SQL Server, when you have a graph table, it still behaves very similar to a normal table, so you could have additional columns and things like that. And one of those columns would be basically a property, some kind of attribute describing the entity called person. In this case, it would be something like ally or foe, which will kind of establish, you can see here that I've just got one edge and it's called knows. And then through that edge I describe how they know each other, so I don't really need two edges to kind of do the scenario. But I've still gone ahead and implemented it this way just so that I could show you a few examples. So why do you want to use a graph database? Well, a graph database is slightly different in terms of the way that it goes about navigating the information. For example, if you have a typical old TP table, you just have a primary key and a foreign key table, and you have only one kind of relationship established between the two of them in terms of how that particular primary key is related to the foreign key. And that means that there's really just a very hierarchical way of going about navigating the data using left outer joins, and sometimes that doesn't really fit well with what we have in a traditional real world scenario, where two people might be related in a number of different ways. And that could often become challenging to represent using a traditional old TP kind of structure. And essentially it would be something like a many-to-many relationship. And for that reason, a graph database actually is very good when navigating these kind of scenarios. You might have seen something similar to this in terms of LinkedIn, where you have your first level connections, second level connections, and third level connections. And essentially you reach your third level connections by traversing the first and the second level connections. And that's essentially what graph databases allow you to do, to kind of navigate to scenarios that might not be directly related to the source, but have some kind of inference. And you might wonder how that would be different from navigating through old TP structures. Well, old TP traditional relational database structures are much more rigid in terms of how that relationship is defined, and that's where graph databases have a significant advantage. So let's get right into it, and in this particular case what I'm going to do is I'm just going to open up the script. I've already run it, so most of the data is already populated, but I'll still go over the script just so that you get an idea about what's going on. The create table script is the same because essentially it's just a table like I mentioned before, but in order to identify if it's a node or an edge, you need to add the syntax as node. And with this, SQL Server knows that it's actually supposed to be storing this data as a graph table. In this example you'll see that I just have two columns. One is an ID column and the other is a person name, and as you can see I've inserted data for a couple of characters from the DC comic universe, and you'll see that in this particular case I've got villains as well as heroes, and then sidekicks or other characters as well. This is what typically a node looks like. I've also created another node further down which is location, and you can see that in this particular case I've created a table, and I don't have a primary key or a identifier column in this particular case. It's just a simple city name, and then I've inserted a couple of cities here as well. Now the relationship that we want to establish, like I mentioned before, is that we've already created the node for the hero or the villain, and then we've also created a node for location. So next we need to define the edges. Now edges basically just define the relationship, so that will be the arrow in the ER diagram, but in a graph database it's actually a table. So you can see that we've got a table saying against, in which I would store information about which villain the hero has fought against, and then you also have another table called edge width, which is an edge that stores information about which heroes have worked together. Now while doing this particular example, one thing that I find particularly irritating is the fact that you can't reuse existing identifier columns like primary keys on your existing tables. Instead, the node ID, as you can see here, has to be fetched from the node table using whichever name that you want. So you can't really reuse the ID column that I had generated here, and that makes it a bit difficult to go ahead and write easy to read insert statements for loading your data. It's actually a bit cumbersome, and you'll see that here, because if I'm trying to establish a relationship between the Joker and Batman, I need to go ahead and insert that into an edge called against, where I find the node ID of Batman and the node ID of Joker and insert it into this edge. So just to give you an idea about what the node looks like, I'm just going to go ahead and query it right now, and you'll see that every node basically contains a JSON that uniquely identifies that row. And here inside the JSON you'll see that the node ID is actually 4 instead of 5, and that makes it difficult to go ahead and really establish a relationship between internal identifiers that we have here with identifiers used by the graph database. This will become especially challenging when we're working with joining graph tables with existing relational databases to kind of merge data sets across the different type of databases. Now for the purpose of this example, I've already inserted a couple of rows, so you'll see that I've inserted 2 rows for Batman and Bane and Batman and Joker. So if I query the edge, it'll actually basically have a relationship saying from and against, or from and to. So you have a unique identifier for the edge as well, which is what we call the edge ID, and then you also have a from ID, which will explain the relationship from the ID 5, which in this case happens to be Batman, and to the relationship ID 7, which in this case happens to be Joker. So let me just go ahead and show that to you real quick so you can see it. So if you look here, I've got the from ID, which was 5 here, which is basically this node ID and not this one here. So you'll see that Batman has fought against two people, which happen to be ID 7 and ID 4. So that's basically ID 7, which is the Joker, and ID 4, which is Bane. You'll also notice that when I inserted the data, Bane was actually row number 4, whereas Batman was row number 1. So you'll see that the ID and the insertion of the data also doesn't really seem to be aligned with what we're trying to do, and that's because of the union statement here. But essentially, because of these reasons, you can't really guarantee a particular ID for your node, and for that reason you need to have some kind of business key that you use to identify the node ID. Now I've also gone ahead and inserted some relationship with in the with node, or in the with edge, where Batman is allied with Robin and Wonder Woman and Superman, and Batman is also allied with Flash. And just to kind of give you an idea, I've also gone ahead and put Wonder Woman and Flash as an additional relationship. So you'll see that we've got actually a few different types of relationships here. Most people are directly related to Batman, but Batman is also indirectly related to Flash via Wonder Woman, as well as directly related to Flash as well. So this is the data set that I've inserted here, and if I just go ahead and now start querying this information, it'll give a better idea about why this whole thing works. The first thing I need to do is I need to go ahead and join the data from the different tables. So you'll see that I've got a persons table, which is my node, the against table, which is my edge, and then again back to the persons table, only this time I'm giving it an alias person2. The reason for this is because I want to establish the relationship of who fought against whom, and that would be a circular relationship traversing the this particular edge here. So Batman over here would traverse this edge and then come back to the node persons in order to find out who he's fought. So you'll see that we've got person 1, which would give me the hero, fought against, and you'll see this is the edge, which is why it's inside the parentheses, and then you'll see that the second one is a hyphen followed by an arrow, a greater than symbol, because that kind of establishes the direction in which we want this relationship to traverse. So go from node into the edge and then back to the node. Only the second node would be called person 2, even though it's actually the same node itself. And if I run this right now, you'll see that I'm not really putting any condition in terms of who I want to identify, so it'll show me all relationships. So you can see that in this particular scenario, Batman has fought two people, so we've got Batman and Joker. We've got Batman and Joker, Batman and Bane, and then Flash and Bane. So this kind of makes sense because this is a very straightforward relationship where we've got a kind of like a manager to employee relationship thing, which we typically do. Most of the time the idea would have been like, if you were doing this in previous examples, a typical interview question where you'd use some kind of ranking function to identify child entities. But in this particular scenario, you can see how the edge actually helps us traverse to find out the relationship. Now the second thing is, I would also like to go ahead and show this example where I'm saying people who know Wonder Woman, or people who Wonder Woman knows. So the first step here is, again, I'm doing a join between person, with, and person, except person gets two aliases, first the source and the destination. So if I go ahead and execute this, you'll see that I'm basically, it's the exact same query as before, except this time I'm filtering for Wonder Woman. And through this we can identify the relationship and say that, yeah, well, Wonder Woman knows Flash, which is correct because that's what we inserted here. And you'll see that the from node is Wonder Woman and the to node would be Flash. That's why this query works. However, this is not the only relationship. The other relationship is people who know Wonder Woman. So the idea is that Wonder Woman knows Flash, but there are other people who know Wonder Woman, and there is a reciprocity to that. So we need to go ahead and flip the direction here. So you'll see that I've still got person 1 with and person 2, except this time the source is person 2 table and the destination is the person 1 table. So if I run this, you'll see that we'll get Batman and Wonder Woman as well. So you get like Wonder Woman knows Batman and Wonder Woman knows Flash, by executing this together in a union all, we get to know who are the people that Wonder Woman knows. And this is one of the challenges that you have with working with these kind of graph databases in terms of the direction in which the relationship traverses. And sometimes you'll have to do things like this to kind of get all the different scenarios available. The last thing that I wanted to show you here was here where we're looking at people who know Wonder Woman and have fought with Bane. So we already know the people who know Wonder Woman is basically Flash and Batman, but we also know that Batman is the only guy who's actually fought Bane. I think so. I don't remember Batman is the only guy who's fought Bane. So in this scenario, you'll see that we've actually joined the table a number of times because we've got person 1 with, or the edge with. So person 1 is an ally of person 2, and person 2 has fought against anybody in person 3. So in this particular scenario, you'll see that I've got one arrow which is basically pointing towards person 1 and an other arrow that's pointing towards person 3, because person 2 in this case is basically the bridge between the person 1 and the person 2. So what we're trying to say here is Wonder Woman is basically the person that we know bridges the gap between the source and the destination. So you'll see in this particular case I'm saying that people who know Wonder Woman, so Wonder Woman has to be person 1 because she's the source. So anybody who knows Wonder Woman would be basically just Batman and Flash. However, between Batman and Flash, the only person who's fought against Bane, who's person 3, is Batman, which is why when you run this query you get Wonder Woman, Batman and Bane. This might take some getting used to, but essentially the idea here is that the lesser than or greater than symbol kind of just indicates an arrow pointing in the direction that you want the relationship to be traversed. And this might be for some people just a trial and error thing where they just go ahead and try the different combinations, but essentially once you understand how the bridge with the edge works, it becomes a lot more easier to write the query correctly the first time around. Now to make this a little bit more detailed, what I've done is in the next example I've added 2 nodes because that's what you typically want to do. You don't really just write queries of a single table, you've got multiple tables. So I've added location here as well, and inside location you'll see that we've got different cities. And Gotham obviously is Batman, Superman is Kansas, Themyscira is Wonder Woman, and Central City is Flash. And again we've got an edge defining the relationship between the person living there and the city. In this scenario again we need to go ahead and populate the edge, so I've gone ahead and found out the source, which would be Batman, the person ID, and then the location ID. So the from would be Batman's node ID, and the destination or the to would be Gotham or the location ID. And so I've inserted data for all the heroes and their respective cities. Next thing I'm doing is I'm basically saying find the people who live in Gotham. So this is a straightforward relationship that we had, very similar to what we had earlier where we were talking about this query here, where we're basically just saying go to person 1, find out the relationship, and then join back to itself. Except now I'm not joining back to myself, I'm joining back to the location table. So this relationship kind of makes sense just by looking at it. We're saying find the people who live in this city, and the city is Gotham. And in my scenario I've gone ahead and mentioned that Wonder Woman lives in Gotham. Okay, instead of Themyscira I've mentioned Gotham there. That's basically it. And the next one is basically find people from Central City who fought Bane, which in this case would be Flash. So you'll see that again what I've done here is I've said person, the city name is Central City, so that's a source. Anybody who lives in Central City would have to be identified by joining back to the person table, and then whichever that person is would be joined to the against table to find out if they've fought anybody else back in the person node. And through this relationship we get to know that Flash, who lives in Central City, has fought Bane. So as you can see, there's really a different way that we understand how this data flows from within a graph database. The way that you query the information is a little bit different than actually understanding how the data works. You don't really need to know which is the primary key table, which is the foreign key table, how that relationship is established, and it's more intuitive. It's more natural for us using the English language to kind of understand how this relationship works. Obviously, there are some challenges in terms of traversing multiple nodes and being able to traverse in both directions. There are some limitations, but hopefully that all will get sorted out in the next iteration, and we'll have a more stable, a more fully functional graph database available to us. Well, that's pretty much it in terms of introduction to graph database inside of SQL Server 2017. I will be posting these scripts in the link below, and I hope you enjoyed this video. Thank you for watching.